As customary, I'm using denatured alcohol to clean the 888 filler rod. Take a look at the results. Just coming out of the tube, there's still a need to clean the rod. Metal itself has been cleaned with denatured alcohol. It's very clear that the weld process of this metal the first time around was not going in the direction we wanted it to. Made a genuine mess out of the Pyrex. I'm using denatured alcohol now in a bore brush. See if I can actually restore this. Well, this is certainly much improved, and we have the added advantage of being able to turn the glass over. So go ahead and clean up the electrode. Again, I'm using a sharp point in this case because I want to be able to go right into this area. Note too that I'm using a non-thoriated electrode, and that this electrode is safe to use in all environments. Use seriated, lanthanated, they're much safer around the shop, and they're easier to handle. We'll go ahead and set up our electrode, and just snug up the back cap a little bit here. Notice the filter's still clear. See daylight through it, so the gas lens is working properly. Again, we reverse the glass. Probably, just around a 1/4 inch there. Snug up the back cap. And again, we're going to tack weld this on each side. Okay, and again, we're using the Weld Mold 888 filler this time around. High tensile, chrome and nickel content, moving into a material that works better with steel or low alloy. Welding could be considered much like body and fender work. It's 90% preparation and 10% welding. And I'll start by tacking the corners, opposite corners of this bead area, and we'll go from there. We'll see how the metal behaves using Weld Mold 888 instead of the 750. This is a really strange metal, and so it makes for a good project. I'm going to start building up a bead in this area here. Again, using the Weld Mold 888, it does seem to be working well, and we'll see what we can do from there.
Pay close attention to the arc stability of the HTP America 221 TIG machine. This is inverter TIG technology, and you can't beat it for stability. I'm also enjoying the water-cooled TIG handle, which enables me to weld for long periods of time without fatigue.
In the process of running the first bead, I stayed over to this side and down to the root. In between passes, I cleaned the area up with a stainless steel brush. And one thing that'll make this a bit easier is to raise this portion of the piece up so that when I'm welding straight down, and my next pass will be burning through this and into this side of the material. As you can see, this is a hot pass. It overlapped the other pass and it burned into both sides this time. We're looking really good right through here. And now I'm going to come back and I'll pick this up right here and burn through to the root of this and into the base metal here and come off of this end.
I'm very pleased with the results of this pass. Now I'll make a bridge pass over the entire area. One of the major advantages of using TIG is that there is no undercut on the edges between the passes or into the base material. This is really advantageous when you're trying to make a repair like this, or in any welding case, a quality weld does not have undercut.
If you're watching carefully, you notice that I made a single pass here with a real slow weave back and forth and filled between the two V areas. And now we're really making progress. I'll move over to the other side before I continue with this side. Let it cool a bit. Notice how that 888 is doing so well.
So as I fill this V, the goal is not a stack of dimes like we're welding aluminum radiators. This is a steady filling kind of movement, and the idea is to get a total fill of this area. I'm burning into the root, and you can see that there will be no voids between each of the passes. When this weld is completed, you'll have a single piece of solid, strong weldment in that V. Notice that I make one pass after another while the metal is still hot. The idea is to leave no voids whatsoever. And listen to how successful the HTP 221 Invertig machine is at keeping a steady, ongoing, and rhythmic arc.
After grinding, it seems like we've done a pretty decent job here. There are a couple of very minor spots to touch up. The objective here, obviously, is to make sure there are no voids and no occlusions in the weldment, and we've accomplished that. The finish shaping will be done with a belt sander, but this was done simply on a grinding wheel with a great deal of care, and you can see that it's starting to actually get there. We're real close to the original shape, and in fact I've built it up so it's thicker in this area that was susceptible to breaking in the first place. One of the things that has come to my attention in the process of all of this is that there is a very slight hairline crack right here. It happens to be right in line with the pin that went through here. The story goes that this handle swung around and hit the base of the lathe with such force that it snapped across here, and given the amount of force on the pin that goes through the shaft, it would not be surprising that this has a hairline crack. We may address that. In fact, I probably will, and I'll show you how to fix something like that as well. You can see that the crack actually goes into the inside here. It's a hairline right here and on the outside.